review last night. We are just going to go over it, make sure we understand all the parts of it. That test on Monday. So here we go. Number one, you should have looked at that page. And on that page, there's a X and Y chart. There's only one thing that I really care about. On there, it says somewhere around -3, it says 0. Yes? Why do I care about this part right here? And this is f of x. Why do I care about that one only? Because my y is 0. What does that make this? My x-intercept. We can call this thing an x-intercept. We can call it a root. We can call it a 0, right? All these are synonymous. They all kind of mean the same thing. So if this is my root, what does that make my factor? My factor, which A says, determine one of the factors without using a calculator. Right here, because of this, I know that one of my factors is x plus 3. Okay? B says completely factor without using a calculator. Well, since I know that this is a factor, what do I know that it does? It goes into the equation perfectly with no remainders. Yes? That's what this whole factor thing means, right? So I can do I have to use long division? What other one could I use? I would use synthetic. What always do you have to divide by? What's the number out here? The root, not what's in here. We are getting those things mixed up so much. That's why I want to keep going over it. The root, which is -3. And then I go 1, 0, 0, 27. Remember? It's x cubed plus 27. The 1 is from right here. There's no x squared, so I put a 0. There's no x's, and then 27. You have to walk it all the way down. Bring down my 1. 1 times -3 is -3. -3 times -3 is 9. Add those, 9 times this, -27. Add those, you get a 0. That means that x plus 3, that's one of the factors, times what's left over? Well, where does this start with? X what? X squared, always 1 minus what the biggest one was up there. X squared minus 3x plus 9. Now, if it says completely factor this, and it says over the imaginaries, okay? It says completely factor. Is this completely factored? Probably. No. I have to check a couple things. First, I need to check, is it factorable by a perfect square? Well, the square root of this is x. The square root of this is 3. 3 times x is 3x times 2 is 6x. That's not a 6x. So I know it's not a perfect square. If I try my other things, I need two numbers that multiply to a 9, but same signs tell me add to 3. Are there going to be any numbers that multiply to 9 but add to 3? So this is not factorable using my double bubble way. So when all else fails, what do I have to use in order to try to find roots? Quadratic equation. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. The reason we've showed you this before we got to this lesson is so you could use it. That's why this guy has, you've done this. Okay? So, opposite of b is 3 plus or minus the square root of -3 squared minus 4 times 1 times 9. By the way, I have seen this on the test, and it's not done correctly very often, which all it is plugging in and doing order of operations. Does everybody see what was my first step?
Okay. Isn't it supposed to be a -b squared and the other one's supposed to be b?
No. the opposite of b plus or minus the square root of b squared. Now, because if you did the negative in here, it would just, are you saying the negative outside of it? This is the way it is.
Yeah, you just like to switch it. No.
Then I just simplify this using order of operations. Nothing I do out here. 3 plus or minus the square root of negative 3 squared becomes a 9. 4 times 1 is 4 times that is a 36. All divided by 2. Combine these guys. That's the only next step I'm going to do. 3 plus or minus the square root of a negative 27 over 2. 3 plus or minus. This turns into a I, and then the square root of 27, I'm just doing this as scratch paper, breaks down into 9 times 3. Yes? And the reason I did that is because this has a square root, turns into square root of 3 over 3. 3 squared is a 3. So what do I have outside, though? Because of this negative, it's not just going to be 3, it's going to be what? 3i square root of 3 over 2. With me? And if they ask me to do this, then I would write it like this. X plus, and the first root is 3 plus 3i square root of 3 over 2, and x plus 3 minus 3i square root of 3 over 2. That would be completely factoring out. Now, I will tell you, I'll give you a hint. On the test, this right here will be factorable much easier. I made sure that you didn't have to use a quadratic for this question. But there is a question on the test that you possibly might have to use a quadratic, so I wanted to make sure that we went over it before you got to the test. Possibly. You have to know where all this stuff comes out. It's all fair game. We've got to put it all together. Why did the i's come out, Flo? Negative under what? Square root. That's any time from now on that we have negative under square root, that's going to pop out. Does that make sense? That would be completely factoring in. Then if I was determining all the zeros, so for this one, can I pretend it's something else? Is that okay with everyone? Do you guys understand what I'm saying? Pretend that when I factored this, I would have got nice bubbles like this. Pretend that's what I would have got. What would be my zeros for this one? And you could write it just like that, and that'd be fine by me. These are ordered pairs, though, right? So how else could I write it? Negative 3, comma, 0. 1, comma, 0. Negative 2, comma. Are you with me on that? This page is going to be huge. All right, so that's all of number 1. Number 2, determine whether x plus 3 is a factor of this whole thing. Notice, does it tell you which way to use? Does it tell you which way to use? What are 2 ways that I can use to see whether it's a factor? Synthetic or long division. So for this one, you get to choose. Some other ones later on, you're going to have to do long or synthetic, but for number 2 and number 3, it looks like, you get to pick whichever one you want. So I'm going to do synthetic. Since x plus 3 is the root, or is the factor, what's the root of that? Negative 3 just happened to be the same root. And what do I put down? Does this walk all the way down from 3 to 1 to nothing? Yes, so I can just write the coefficients. 1, 8, 7, 5. So, bring it down. 1 times the negative 3 is negative 3. Add that together, you get 5. Multiply that together, you get negative 15. Add that together, you get positive or negative? Negative. Multiply this times this, and you get a 24. Do I really care about what this answer is right now? Why? It's not a 0 here. So what does that mean? Not a factor. Number 3, these things are scaring me. These ones are supposed to be easy. There is, for the first part of 3, you don't have to do any math. You just have to understand a concept. It says, now there is one part that I messed up on. It should say determine f of negative 1. You need to change that. Why does that matter? F at negative 1 would do what to what I was dividing by? You have this right here. Do we know what f of x is? Do we know what it is right now?
No.
We just know we took some function divided by x plus 1, and here's what we got. This was what we got. Okay. They're saying determine f at negative 1. What does it equal? Well, the problem is you can't plug x in up there. You don't know what this big equation is. Are you with me? But there's a rational, the remainder root theorem. Right? The remainder theorem says if you take the factor of this, which isn't this the factor of that, and divide it, whatever your remainder is, that will be like you plugging in negative 1 into that equation. So if I take f at negative 1 and I plugged it into this equation, what should I get out? 18. That's by the remainder theorem. What? This is the factor. This is the root. Whatever the factor, when you divide it, whatever the remainder is, will be the answer of if you plugged in the root of that factor. That's the whole theorem that says that. There is no math for part A in that number 3. It's already done for you. Does that make sense? Now B, it says determine f of x. How can I figure out what f of x is? No, well, Okay. We did this in class. What is 10 divided by 2?
5.
Y. 2 times 5 equals, hello. What does this say over here? F of x, what? Divided by x plus 1 equals all of this. How do we say that you could check this? By taking these and doing what with them? Multiplying and adding the what at the end. Yes, we did that as homework. So we should go x plus 1 times x squared minus 8x minus 2, and then add 18 out here. Notice this guy is out here all by himself, because I have to multiply these two things together first and then add the 18 in last. So I have to distribute. This times this is x cubed. This times this is negative 8x squared. This times this is a negative 2x. Done with this guy. This times this is a plus x squared. This times this is a minus 8x. This times this is a negative 2. And then I can put my plus 18 out there again, because now I'm done distributing. Combine like terms. Okay, are there anything that are like this guy? Nope. X cubed. Anything like this guy?
Yes.
Yes. Negative 8x plus x is going to be a negative 7x squared. I have negative 8, I add 1, I still have negative 7. Notice what I do too to show myself when I've used something so I don't get confused, because there's a lot of stuff up here. Negative 2x, and I minus 8 more. What do I get?
10.
And I used it, and I used it. Negative 2 plus 18 is a
16.
positive 16. And what did I just solve for? What is this right here? That is f of x. Let's say I have extra time on the test. How can I make sure that this works? I can take synthetic division. What's my root of this? What's the root of this guy? Negative 1. Couldn't I do synthetic division of negative 1 and make sure I get 1, negative 8, negative 2, and a remainder of 18? I got extra time on the test. I might as well check my work. Are you with me? What else could I check? Do you remember how I said if you plugged in negative 1, what should it equal? Negative 1 cubed is what? Negative 1. Negative 1 squared is
1.
times the negative 7.
Negative 7.
Yes? Negative 10 times the negative 1 is a? And plus 16, yes? With me? Negative 7 and a negative 1 is negative 8. Negative 8 and a positive 10 is 2. 2 plus 16 is 18. Isn't that what I said should happen if I did this correct? That's that remainder root there. Yes?
Yeah.
Okay. No, part C says determine whether x plus 2 is a factor. Okay? Do I have to do long division? What can I use? Synthetic. And if it's a factor, what would my remainder be?
0.
But if my factor is x plus 2, what do I have to use to use? Negative 2 is going to be my root, and that's what I use for synthetic. What? Not 2. Negative 2. You could do that. I wouldn't do that because of my next question. Watch what I'm talking about, Joel. You're going to waste a ton of time if you plug that in. Here's what happens. 1, negative 7, negative 10, positive 16. Bring down the 1, negative 2, negative 9. Yes? Am I doing this all correct? 1, negative 2, negative 9, positive 18, 8, negative 16, 0. Is it a factor?
Yes.
Part D. Part D says determine f at negative 2. Okay? What did we just say up here? If you plug in the root, it should equal what the remainder is, correct? If I plug in a negative 2, what should I get out?
0.
Why? Because my remainder was a 0. That's using that root theorem again. See, are you with me? Now, the last part, E, says completely factor it. Well, what do I know is one of my factors? What did I just prove right here that one of my factors is? No. That's what we've got to stop doing. Negative 2 is not a factor. Negative 2 is the root, which, yes, the root helps me find the factor, but those two are not synonymous. I said root, x-intercept, zeros. Those are synonymous. Now, yes, the roots come from the factors, and yes, you can get the factors from the roots, but those are not synonymous. They do not mean the same thing. They come from the same area, but they are not the same thing, and that's where we keep screwing up. No, negative 2 is not a factor. What is the factor? X plus 2 is the factor. The root is whatever makes the factor 0. Now, what times x plus 2 would get me to that whole thing up there? What did I just do right here? Did I do my synthetic division? Doesn't that mean that if I use this right here, which I use that this would be my stuff that's left over? So, see how I've already done all my work for this problem? I'm putting it all together in this one. X squared minus 9 plus 8. But it says completely factor, doesn't it? So I got to look at this guy. Is that factorable any further? So I'm going to check. How come I can double bubble right away? Because there's a 1 right here. Does 8 have a perfect square? No. So I can skip all that. There's no greatest common factors. I've got to start seeing that faster. I shouldn't have to keep, first, does it have a greatest common factor? No. Second, it's a special case. That needs to go through my mind, but it needs to start going quicker. Same signs, both negative. Two numbers that multiply to 8, but add to 9. Negative 8, negative 1. That would be completely factored out. Alright, now we're going to get a little quicker. 4, by chunking, 9x squared plus 30x minus 11. Okay? I can, by chunking, I'm going to say that z equals 3x. So I'm going to rewrite this as z squared plus 10z minus 11. Yes? Okay? Break this down into two bubbles. Z, two numbers that multiply to 11 but subtract to a positive 10. Well, that would be 11 and 1. And the bigger number is positive. So it would be plus 11 minus 1. That's old school factoring. Now, what do I need to replace? Instead of z's, I need to take back and put in 8. So it should be 3x plus 11, 3x minus 1. 5. Factor by grouping. Notice, do you see where most of my time should be spent on this test? Should it be factoring? Did you see how fast that took me? That's because you should know how to do that. Remember, whatever the square root of that is was 3x, right? If that goes into that, that's what I'm going to do it by chunking. Because these have a common factor of 3x, but this one didn't. So that's how I knew I was going to try chunking. All right, group this together. Group this together. Notice I put that negative inside, and I put a plus sign. We've done this a bunch of times too. X squared, x minus 3. Factor out a negative because I need this to be a positive. I need that to get to be a positive, so they have a negative 4 in common, and I'm left with x minus 3. These guys have an x minus 3 in common. What am I left with? X squared minus 4. Am I done? No. What is this right here? Difference of squares. So I'm left with x plus 2, x minus 2. All this should be coming a little easier because Notice it's a lot of your old stuff that we're doing together. Number 6. Factor x to the 4th minus 29x squared plus 100. Do you see how this is an x to the 4th and an x squared? Remember I told you could treat this just like it was x squared and just x? Okay, so first I should check something. This has a square root, right? X squared. This also has a square root, which is what? But 10 times x squared is 10x squared times 2 is 20x squared, right? Is that what's sitting here? So it's not a perfect square, so I can go and just bubble. I'm going to put x squared here. I'm going to put x squared here. Same signs means add. Both signs are going to be negative, so I can put my negative here. I need two numbers that multiply to 100 but add to 29. Now, what else popped up down here? What is this? Difference of squares. What is this down here? Difference of squares. X plus 5, x minus 5, x plus 2, x minus 2. Told you these guys are going to pop up all the time. Number 7. 3x to the 3rd minus 36x squared minus 108x. What do I first try to do? GCF. What is it? Oh, thank you. So they have a GCF of 3x. And what am I left with? X squared minus 12x plus 36. Now, does this have a square root? Yes. Does this have a square root? Uh-oh, I better check for a what? What do I need to check for? I've been doing this 5 or 6 times already. I need to check for a perfect square, ladies and gentlemen. X times 6 is what?
6x.
Times 2 is what?
Plus.
What's sitting right there?
Right.
So it's a perfect square scenario. So I've got 3x, x, 6 squared. Now, what sign goes here? Negative, because this says, yes, same signs. This says they're both negative. So that would be my answer to that problem. Number 8. What's the rational root theorem? What's the rational root theorem? You take the back factors. We called them, what do we call them? F and Q, P and Q, right? P and Q. P was all the factors of 3. Well, what are the factors of 3? 1 and 3, right? Plus and minus. What's the factors of this guy? Just 1. So what are the possible roots for this one? Plus or minus 1, plus or minus 3. That's it. You with me? Now, I then use that to help solve that. So I say, okay, it's possible that 1 goes into this, right? And I use synthetic. 1, negative 4. Now, what else do I need to put here? 0, 3. Bring it down. 1. 1 times 1. Negative 3. Negative 3. Negative 3. Negative 3. 0. Correct? You with me? What did I just prove? X. What's one of my factor, or what's my root for this one? 1 is my root, correct? What does that mean my factor is? X minus 1 times what's left over? X squared minus 3x minus 3. You with me on that? Then on the test, you could probably keep factoring this. Some of the ones that I picked, I just tried to make it the best I could. So then you try to factor this. Okay, two numbers that multiply to 3 but subtract to 3, that's not going to work out. So what would I have to use? My quadratic. I'm not going to go through that whole quadratic again. That's what took us so long on number 1. Number 1 will not have the quadratic, but these guys down here could have to use the quadratic. Are you following me? How do I know to use the quadratic? Are there two numbers that multiply to 3 but subtract to 3? So that's when I know I have to use my quadratic. That's not possible to factor it that way. Okay, use long division. Number 9, use long division. X minus 2. How does that go into 2x cubed minus x squared minus 13x minus 6? Okay, I need this right here to become this. So I need 2x squared. This times this becomes 2x to the third. This times this, right here, becomes a negative 4x squared. Remember, I am subtracting, so what do? I add and I change my signs. Cancels out like it should. I get a plus 3x squared minus 13x minus 6. Now I need this to become that right there. So I need a plus 3x. This times this gets me to a 3x squared. This times this gets me a negative 6x. But again, I'm subtracting, so I add the opposite so I don't make mistakes later on. With me? These cancel out like they should. This becomes a negative 7x minus 6. This times a negative 7 would get me there. So this is a negative 7x. This is a positive 14. Combine like terms. And this became a 8. No, yeah. 8. And I get 8 over x minus 2. That would be my final answer for that one. Number 10, use synthetic division to solve this. Well, what did they give you? It says f at negative 2. That means that f at negative 2 is the root of my whatever I was dividing by, right? So I can just use the negative 2 in my synthetic, and boom, I put a 1, 1, negative 16, and a negative 16. Bring this down. 1. 1 times negative 2 is negative 2. This becomes a negative 1. That becomes a 2. This becomes a negative 14, which becomes a positive 28, which becomes a positive 8. Yes? So then my answer would be x, because it asked me to divide, right? So it'd be x squared minus x minus 14. And you could put plus 8 over, if this is my root, what's my factor? What was I dividing by, actually? X plus 2 would be the thing that could go under here. Or I guess I would accept remainder 8 too. Sorry. You're correct. Questions? Number 11 comes from yesterday's work. You should have taken and gone 45 squared. What can I break that down into? 40 plus 5 squared. 40 plus 5 squared. So this becomes 40 squared plus 2 times 40 times 5 plus 5 squared. 1,600 plus, that should be 10, so this should be 400 plus 25. So So that should be 2025. Yes? 12. That formula that we did yesterday was, the bigger number is 12, so I'm going to make sure I put that first. 12 squared, yes, plus 4 squared, all squared should equal 12 squared minus 4 squared, yes, squared plus 12 times 4, and all that squared. So then when I just did this, you got 144 plus 16 squared. 144 minus 16 plus this became what? 8. What is that? Anyone have that? You guys can do it? 96. Then we had
Square.
Nope. Yeah, I got it.
and then when you add these together, what did you get? 160.
Yeah.
And what did you get here? And 96. So what's my Pythagorean triples because of this? 96, 128, and 160. Thirteen. If it says list all the possible roots and it's multiple choice, okay, what does that mean you're using? How do I find the possible roots?
P and Q.
How do I do P and Q? P is the factors of last number, factors of first number, and then my possibles, I take all my P's and divide it by all my Q's, plus or minus. Yes? Everybody remembers that theorem that we did? Huh?
I really am going to review all of this.
Good. 14. If I give you a factor, how can you find the other factors? You use synthetic division or you use long division to see how many times it goes into it and then break them down. That's what we've been doing the whole time, except this is going to be multiple choice.